of all, read the question carefully and try to solve this problem yourselves, and stop the video, and you can compare at the end. Now we will solve this problem. As you know, first of all, we need to draw all forces acting on each object. So basically free body diagram. So let me start with object mass 2. And we have a horizontal force F. There is a weight, its own weight, M to G downward. And since we have an object on it, there will be a reaction force, normal force between these two objects, and which is perpendicular to the surface. So we can say there is a, let's call it N0. This part should be 90 degrees. And of course there is a normal force with a horizontal surface, let's call it N1. No friction force, so we have these four forces: weight, two normal forces, and one horizontal force. And we know that this object will move in horizontal direction to the right, so this is the direction for the acceleration. As usual, let's choose our axis, x and the y axis directions. This is a standard problem, so horizontal direction will be x, vertical direction will be y. As you see, NO has two components, horizontal and vertical. So let's try to write this NO in terms of components. This part is theta, so if we draw this vertical line 90 degree, here 90 minus theta, so it means this part will be theta. So let me write it here. Horizontal to the left we have a NO times sine theta. Vertical downward we have a NO times cosine theta. So these are the components for NO. And in the horizontal direction to the right we have a F. Vertical downward we have a weight. Vertical upward we have a N1. And we know that this object mass M2 moves to the right with acceleration A. So now let's write Newton's second law in horizontal direction. There is no need to write it in vertical direction because it will not move in vertical direction. So we know that the resultant force in horizontal direction should be equal to MA. Resultant force in horizontal direction equal to F minus NO times sine theta should be equal to its own mass M2 times acceleration. Now let's come to the first object, M1. Again, let's draw free body diagram. We have weight, its own weight, M1G, and the same NO, it will be directed in this way, N0. And we know that this object also needs to move with the same acceleration as the M2. Only in this case, it will not slide up or down. If it will have the different accelerations, then it means there is a sliding. In order to avoid the sliding, they both need to move with this absolutely same acceleration. And again, XY direction, NO has the two components. This part is this angle is 9 theta because this part is theta. So this part will be 90 minus theta. So this part will be again theta. So horizontal force will be equal to NO times sine theta. The vertical one, vertical upward, it will be NO times cosine theta. Downward we have a weight. This is a free body diagram for the object 1. And as you see, this object moves only in horizontal direction. There is no motion in vertical direction, no motion. So it means resultant force in vertical direction equal to 0. Or we can say N0 times cosine theta minus M1G. This is the resultant force in vertical direction. Actually, it should be equal to M1 times acceleration in y direction. And we know that acceleration in y direction equal to 0. So this part will be equal to 0. It means N0 times cosine theta minus M1G equal to 0. From here, it's obvious that NO equal to M1G divided by cosine theta. This part is very important. Now we know the value for NO. And we can write Newton's second law in horizontal direction also. In horizontal direction, we have only one force, NO times sine theta should be equal to M1A. And M1G divided by cosine theta, this is NO times sine theta should be equal to M1A. We can remove masses. And the acceleration, we have a G times tangent theta. Now we need to find force, so we need to come back to the first equation. As you see here, acceleration we already know, NO we calculated, so we can easily find force. So let me rewrite the first equation here. Force minus NO sine theta equal to M2A. So from here, force equal to NO sine theta plus M2A. NO equal to M1G divided by cosine theta times sine theta plus M2 times acceleration, which is G times tangent theta. So shortly it will be like this: M1G tangent theta plus M2G tangent theta. So we can take G tangent theta out of the parenthesis, so we will have this kind of answer. This is a final answer. So read the question and try to solve this problem yourselves, then you can compare with my solution. Again, free body diagram. Let's draw our hamster and the block. First, let's start with hamster. The shape is not important. Let me draw like this. Free body diagram, downward weight. This direction we have a normal force, let's call it NO or N1, and no friction, and the block at rest, it will not move. It means there is one way this object, this hamster, will move only in this direction, and this will be its acceleration. As you see, this is a standard question. Normal force has two components. We can solve it in, let's change the axis. So let's write weight in terms of components. So weight in this direction will be M1G cosine 40, angle is 40, let's take it as alpha for now, and this will be M1G sine alpha, and this is a reaction force. And we know that this object moves in this direction. It means acceleration or motion in this direction equal to 0. So we can say that normal force equal to M1G cosine alpha. This part is important because there is no motion in this direction. Now let's draw our block. Free body diagram. Weight M2G, this force NO there will be a reaction force upward, let's call it N1. Actually, we need to find this force, because only this force will act to the spring scale, and spring will show you the same N1. And of course, friction force in this direction. And as you see, only N0 has a X and Y component. Let's write it in this way. In this direction we have so first we need to find angle, this angle alpha, this is alpha, so NO times cosine alpha. In this direction we have NO times sine alpha. So let me draw it again, free body diagram. Upward NO, downward we have NO cosine alpha, and downward we have a weight. Horizontal we have a friction force, because block is not moving, friction is very big, and in this direction we have a NO sine alpha. And we know that this block is not moving in horizontal direction. It means these two forces are equal to each other, but this information is not useful for now. And in vertical direction also no motion. It means acceleration in vertical direction equal to 0, so it means N1 equal to NO cosine alpha plus M2G. So we can say N1 equal to M2G plus NO cosine alpha. NO is given here, so N1 equal to M2G plus M1G cosine alpha times cosine alpha, it will be square. So let's find it. M2 is mass of the block, which is 800 grams, which is 0.8 kilogram, gravity approximately 10, mass M1 hamster 200 grams, 0.2 kilogram, 10, and the cosine square 40 degrees. So from here N1 equal to, let's calculate it, 2 times cosine 40 times cosine 40 again plus 8. So answer is 9.17 newtons, but we need to find it in terms of grams. This is equivalent to 0.917 kilogram, which is 917 grams. This is the final answer. The scale will give us this value, 917 grams.